This is going to be just a few of these problems from the absolute value inequalities worksheet. And I just chose a few here. I'm going to do 6, 14, 20, and 26. But remember your goal on these inequalities and absolute value both is to get the absolute value sign by itself. So I'm going to move this to the other side. So what I have here is the absolute value of m is greater than 2. Now, just for a minute, I know this is greater than, but to find those magic points, remember we're going to pretend that this says the absolute value of m equals 2. You don't necessarily need to write that down, but you just kind of, that's what you're thinking. Remember, for this to be 2, the absolute value, that m is either going to equal 2 or m could equal negative 2. Because when you take the absolute value of negative 2, that would give you the positive 2. And the reason you do that is to find these two key points. So what I'm going to do when you graph here is find your 2 points. So there's 2 and there's negative 2. Now at this point, this is where you decide if you're going to fill these in or if they're going to be open. Now since this is strictly greater than, or if it was strictly less than, either one, it's going to be open. Okay. I'm going to make open points on these two magic things because it can't equal 2, but it can get mighty, mighty close to 2. So that's just kind of where we're going to start off. Now, if it had the or equal under here, we would fill these points in. Now, after that, you've got to decide where you're going to shade. You're either going to shade in the middle or it will shoot off on either side. So I just pick any point that, and I always like 0 just because it's the easiest. And I plug it into my original. The absolute value of 0 is 0. 0 minus 2 is negative 2. Well, negative 2 is not greater than 0. So 0 didn't work. Now notice 0 came between these two, so that means nothing between these two key points would work. So it's going to have to be the values that shoot off to the left and the right. Now if you don't believe this, you can plug in some values and check it. Like pick something here to the right, anything. There's infinitely many numbers. How about 3? The absolute value of 3 is 3. 3 minus 2 is 1. 1 is greater than 0. You could also pick something over here. You could try negative 10. The absolute value of negative 10 is 10. 10 minus 2 is 8. 8 is indeed greater than 0. So this is your little graph right here. Now in interval notation, this is shooting off to negative infinity. So it's going to be from negative infinity. And then everything's good until you get to negative 2. Since this is an open point, you're going to use a parenthesis. In fact, some books, and I think that one, it would use a parenthesis here instead of an open point. And I'm good for either one. And this is your union because this means and. We're going to pick up at positive 2 and we're going to keep going all the way to infinity. So this would be interval notation. All right, so let's try another one here. Get your absolute value bars by itself. Notice this one, they're already by itself. This one, it wasn't. I had to move the 2 over, okay? So this one's already all by itself. So what I'm going to do just for a minute is I'm going to pretend that this says equals, okay? I don't care what it says. If it says greater than, less than, I don't care. But to find my 2 key points, I'm going to pretend it says equal. If it said equal, one time it would equal 24, and one time it would equal negative 24. Because if this was negative 24, when you take the absolute value of it, it would equal 24. Okay, so I'm going to do it twice. Subtract 6 from both sides here. That's going to give me 9x equals what, 18? So x equals 2. Okay, then I'm going to do it again. I'm going to subtract 6. That's going to give me 9x equals negative 30. Divide both sides by 9. Notice 3 will go into both of those. So 3 will go into that 10 times. 3 will go into that 3 times. Those are my 2 key points. Okay, so again, when you get ready to graph this, here's 2. I don't care about everything else. Negative 10 thirds, you're going to have to approximate that. But there's negative 1, negative 2, negative 3. That's negative 3. It's about right there. Okay, now you need to decide if these are going to be open or closed points. Since it's or equal to right there, I'm going to close them up. So I'm going to close it at negative 10 thirds, and I'm going to close it at 2. Okay, so that's how you find your key points. You pretend it says equals just for a minute and then solve. Now you're going to pick any point. I like to pick 0. Plug it into your original equation. That's going to give me 0. 6 plus 0 is 6. The absolute value of 6 is less than or equal to 24. It worked. Therefore, any point between these two would work. So it looks like this. By the way, a little hint. You'll notice this to be true. If it's less than, and if this is only true if the absolute value is on the left, if it's less than, it's going to go towards the middle. If it's greater than, it's going to shoot off on either end. Okay, interval notation. Okay, since you can include these points, these magic points, I'm going to use a bracket. You put the smaller value first. Things are good until you get to 2, and then that's a bracket. So that's your interval notation right there. Okay. Try this one. Remember, get your absolute value bars by itself. So I'm going to add 9 to both sides. So I've got this 7, absolute value of n over 3 is less than, what is that, 21? And then I'm going to divide everything by 7. So I've got n over 3 is less than 3. Okay, now at this point, once you get the absolute value bars by itself, you're going to pretend it says equals 3. So one time it would equal 3, and one time it would equal negative 3. And again, I'm going to say this. If this equaled negative 3, when I took the absolute value of it, it would equal 3. Okay, multiply both sides by 3, so I see n is 9. Here I get n is negative 9. Those are my 2 key points. That's the only reason I do it. So there's 0, there's 9, there's negative 9. I decide if they're open or closed. Since it's strictly less than, not or equal to, they're going to be open. So I want to open them up. Pick any point you want. And by the way, since it's less than, remember here where it was less than, how it went towards the middle? Guess what? Let's try it and see if it works. Pick anything in the middle. Why not 0? So I could plug it in here. 0 over 3 is 0. The absolute value of 0 is 0. That's indeed less than 3. Okay? Or you could do it here. 7 times 0 is 0. 0 minus 9 is negative 9. Negative 9 is indeed less than 12. So it doesn't matter. But this is what's going to work is everything in the middle. I'm going to shade that in. When I do this in interval notation, it's going to be the numbers between negative 9 and 9. That's how you show that in interval notation. If these would be filled in, this would have been brackets. Okay, if they're open circles, they're parentheses. Okay, last one. Get these bars by itself. So we're going to add 3 to both sides. So I've got 9, 1 plus 8n is greater than or equal to 81. Divide both sides by 9. So I have 1 plus 8n is greater than or equal to 9. Okay, got the bars, the absolute value, signed by itself. So I'm going to take what's inside, and one time I'm going to set it equal to the positive value, and one time I'm going to set it equal to the negative value. And then solve. So I'm going to subtract 1, divide both sides by 8, so I get n is 1. Here I'm going to do the same thing. I'm going to subtract 1, so 8n equals negative 10. Divide both sides by 8. So n equals, let's see, 2 will go into both of those. So what, 5/4? Negative 5/4? Those are my 2 magic points. So I've got one here at 1. Negative 5/4 is what, like negative 1 1/4? I'm going to, because this is or equal to, I'm going to close these points. And here's 1 at 1. Didn't space that. Since this is greater than or equal to, it should shoot off in opposite directions. I mean, I can test it. Try 0. If I put 0 in here, that's 0. 1 plus 0 is 1. 9 times 1 is 9. 9 minus 3 is 6. 6 is not greater than or equal to 78. So you can see it didn't work. Therefore, nothing in the middle would work, so it's going to shoot off on either side. It's going to look like that. When you do this in interval notation, notice it's shooting off to negative infinity. Parentheses will always go with negative infinity because you will never get there. There is no stopping point. But this has a stopping point at negative 5/4. So that's like my break sign. But and, because we pick up over here, it picks up again at 1. It includes 1 because of the or equal to. And again, it shoots off to infinity. So that is that. The only other thing that I might point out is, let me see, that's not the one. There's one here, I was like, ooh, I like this problem. Here it is, number 16. Do you see how absolute value, remember absolute value is always positive. Well, this is a negative value. So think about it, absolute value, I don't care what you plug in here, it's always going to be greater than the negative. So there's really nothing to do here if you can think about this, that absolute value is always positive, therefore it's always going to be greater than negative 11. So on this one it should be everything, all real numbers, which means it would be negative infinity to infinity. And there should be another one like that. I think this one's kind of tricky right here. If you add 10, do you see you're going to get negative 63? And then you would divide by 9, which is going to give you what, a negative 7? Well, there's no way. Remember, absolute value is always positive. There's no way it would ever be less than a negative 7. It's impossible. So on this one, it'd be no solution. So you just kind of have to think about those.